Hello. In this video, we're going to be looking at scientific notation. Scientific notation is really just taking a value, a number, and writing it in a different way, but it maintains that value, so it's equivalent to the first value. And so you might see something that looks like 3 times 10 to the second power. That would be scientific notation. So we have like a number 3, and it's multiplied by 10 to some power. You'll see down here it's 10 to the 4th power. But it's any number that's taken in that form. Now what we're going to do is we're actually going to use mathematics to simplify this in ways that you've seen before based on your understanding. So the first thing is that it's multiplication, right? 3 times 10 to the second power. Now normally you would see this written like this. We would, instead of having an X there, we would just like have a dot, maybe just a parenthesis, and that would actually indicate that it's being multiplied. So now if I took that and I expanded what we know with decimals here, 10 to the second power is 10 times 10. So really it's 3 times 10 times 10, which is 300. So what we would say here is that 300 is actually equivalent, having the same value as 3 times 10 to the second power. Now when we use scientific notation, very rarely would you use it for an example like this. But if that number is a very large number, a very small number, scientific notation is going to allow us to be able to communicate the value there without writing out all these different digits. It's actually going to be a shorthand way of writing it. And so let's move to the second example where it's 4.25 times 10 to the 4th. So again, I'm going to take that and I'm going to write it 4.25 times 10 to the 4th. I'm going to use what we know about exponents to write this as 10 times 10 times 10 times 10, and then it's 4.25. So then I would just do this multiplication out, and so when I do the 10 to the 4th power, the 10 to the 4th power is 10,000. So it's 4.5 times 10,000. And then we have to simplify that, and we get 42,500, which is equivalent to 4.25 times 10 to the 4th. So again, we're rewriting something that looks a little bit different, but it has the same value. It's equivalent to what we started with. So if you're trying to communicate these ideas, either one would be acceptable because they represent the same thing. So those are positive exponents. You saw, a +2 and a +4 as the exponents on the tens. Now we're going to look at negatives. Negative exponents are a little bit different because we're not always quite sure what to do with those negative exponents. So let's start with the same process. 7 times 10 to the -2nd. Is how we'd write that. Even read the same way. These first two are read the same way. And then anytime we see a negative exponent, we're going to move that negative exponent. So we don't really know what to do with 10 to the -2nd, but we can move it. And when we move it, it actually becomes a positive exponent. And so I could move that 10 to the 2nd power, or 10 to the -2nd, to the bottom. And when it does, it becomes 10 to the 2nd. Now, if I had a negative exponent in the bottom, I could move it to the top and make it positive. The 7 is to a +1, so it's going to stay on top. So we're really going to have 7 divided by 10 squared, which is really 7 divided by 100. And so when we have 7 divided by 100, we could do that division. We could write it out and do the longhand division. Or we could remember place value and remember that 7 100ths, so tenths, hundredths, that is 7 hundredths. So we could write it that way as well. Our last example is going to be 5.3 times 10 to the -3rd. And so doing this the same way, 5.3 10 to the -3rd, right? This looks a little bit more like what we do in math class. And then 10 to the -3rd, let's take that 10 to the positive third on the bottom now. And then it's 5.3 up here. So 10 to the third, we can simplify down. That's just 1,000. So I'm gonna erase that and make it 1,000. Now this looks a little bit different, right? A little bit complicated because it has a decimal in here. And most of this, like a lot of times you'd hear math teachers say, I don't want to accept that because it has a decimal within a fraction. And that's just no bueno. However, first off, many times this happens. Second off, if we want to make it look a little bit more what we're used to seeing, we can scale it up and multiply it by 10 on top and 10 on bottom, which is basically just multiplying it by 1, right? 10 divided by 10 is 1. And so now the top is 53 and the bottom is 10,000. So now 53 over 10,000, we can write as a decimal, which is tenths, hundredths, thousandths, 10,000ths. So 0.0053 is read 53 10,000ths. And so we can use that place value to actually write out the decimal. And again, this decimal, 53 10,000ths, is equivalent to this. So we could write either one depending on the situation and what's needed. So scientific notation communicates the exact same value. It just is written in a different way. And sometimes it's more helpful than others, especially if the number is very large or very small. Thank you for joining me with this. Hope to see you next time.